Welcome, dear explorers, to Earth with Nature. Let's embark on a profound voyage today, tracing the timeless journey of a single photon, a tiny particle of light, across 14 billion years of cosmic history. Without pause, let's dive straight into this captivating story, where science meets wonder, as we follow this photon from the dawn of the universe to the very moment it reaches your eyes. Imagine a spark of energy born in the fiery aftermath of the Big Bang, a messenger of light that knows no rest, traveling through the vast emptiness of space without ever aging, untouched by the passage of time as we know it. In the realm of physics, according to Einstein's theory of relativity, time stands still for anything moving at the speed of light, 186,282 miles per second. For this photon, the 14 billion years we measure as the age of the universe are but an eternal now, a single, unending instant. As we trace its path through the cosmic expanse, we'll weave in the story of Earth as a unique haven among countless worlds, drawing from astronomy and planetary science facts to ground us in our place within this grand narrative. Picture the photon weaving through ancient star fields, past nascent galaxies forming in the early universe, as documented by the Hubble Space Telescope's deep field images, which reveal over 10,000 galaxies in a sliver of sky no larger than a grain of sand held at arm's length. These images, captured since 1995, show us light that has journeyed for billions of years, much like our photon, offering a window into a universe teeming with potential. Consider this. How does it feel to know that the light you see from distant stars is a relic of a time before Earth even existed? This journey isn't just about light. It's about understanding our planet's fragile beauty amidst the cosmic wonder, a theme we'll explore through exoplanet mysteries and the search for other habitable worlds. As we follow this photon, let's ponder the intricate dance of physics that allows it to defy time, using vivid examples like the cosmic microwave background (CMB) radiation detected by the Planck satellite in 2013, which is the faint glow of the Big Bang itself, light that has traveled since the universe was just 380,000 years old. This educational odyssey will unfold slowly, inviting you to reflect on humanity's quest for knowledge through tools like the James Webb Space Telescope, launched in 2021, which peers even deeper into the past, capturing infrared light from the first stars. Let's immerse ourselves in this story, connecting the photon's timeless flight to Earth's singular role in a universe of infinite possibilities, encouraging you to seek out more through personal research into the wonders of space and time. Transition with me now to the photon's origin, where we'll uncover how its journey ties into the broader tapestry of cosmic evolution and our planet's place within it, marveling at the science that lets us glimpse the unimaginable. Let's linger at the very beginning of our photon's journey, born in the searing chaos of the Big Bang, a moment 13.8 billion years ago when the universe erupted into being, as confirmed by precise measurements from the Wilkinson Microwave Anisotropy Probe, WMAP, in the early 2000s. Picture an unimaginably hot, dense point expanding in a flash, creating space, time, and the first particles of light, our photon among them, within mere fractions of a second. In this primordial soup, photons bounced endlessly between charged particles in a plasma so thick that light couldn't travel freely, a phenomenon detailed in studies of the early universe by cosmologists at institutions like Caltech. It wasn't until 380,000 years later, during the era of recombination, that the universe cooled enough for atoms to form, finally allowing light to stream across the void. This is the origin of the cosmic microwave background, a faint whisper of that ancient light still detectable today with instruments like the Atacama Cosmology Telescope in Chile. Our photon, now free, began its epic voyage, unaffected by time in its own frame of reference, a quirk of special relativity where its clock is eternally frozen, as Einstein described in 1905. As it sped through the expanding cosmos, galaxies were just beginning to coalesce from clouds of hydrogen and helium, a process observed in simulations by supercomputers at NASA's Goddard Space Flight Center, revealing how gravity sculpted the first stars within a billion years. Reflect for a moment. What does it mean that this tiny particle, born at the universe's dawn, carries the story of creation itself? Tying this to Earth's narrative, our planet formed much later, about 4.5 billion years ago, a mere speck in the photon's ageless journey, nestled in the sun's habitable zone where liquid water, a key to life, could exist, as highlighted by planetary science facts from the International Astronomical Union. While our photon traversed billions of light-years, passing nascent star systems, Earth emerged as a rare crucible for life, protected by a magnetic field that shields it from solar winds, a fact underscored by data from NASA's magnetospheric multi-scale mission launched in 2015. This contrast between the timeless photon and our fragile world invites us to marvel at how unique conditions, Earth's precise distance from the Sun, about 93 million miles, and its atmospheric composition of 21% oxygen, allowed consciousness to arise, perhaps to one day perceive that very light. Astronomy teaches us that the universe holds an estimated 100 billion galaxies, each with billions of stars and planets, based on Hubble's observations, raising the question: are there other worlds where light like this sparks awareness? Let's ponder the photon's path through these cosmic nurseries, considering exoplanet mysteries unveiled by missions like the Transiting Exoplanet Survey Satellite, TESS, operational since 2018, which has confirmed over 7,000 candidate planets, many in zones where life might thrive. This slow exploration bridges the photon's timeless flight to humanity's search for connection, urging you to dive into research on cosmic evolution or planetary habitability, perhaps exploring how the first light shaped the universe we inhabit. As we follow this photon further, let's shift to the vast distances it crosses, linking its journey to the scale of the cosmos and Earth's delicate place within it, fueling our curiosity about the unknown. Now, let's journey alongside our photon as it traverses the incomprehensible vastness of space, covering distances that defy human imagination, all while experiencing no passage of time in its own relentless frame. Visualize this particle of light racing at 299,792 kilometers per second, crossing the 93 million miles from the Sun to Earth in just over 8 minutes, yet taking 14 billion years, from our perspective, to reach us from the universe's farthest edges, a feat measured by redshift data collected by the Sloan Digital Sky Survey since 2000, mapping millions of galaxies. For the photon, bound by the laws of relativity, this immense span is irrelevant. As Einstein theorized, at light speed, time dilation renders duration meaningless. 14 billion years collapse into a singular, unchanging moment. As it glides through the cosmic void, it passes through the intergalactic medium, a sparse sea of gas and dust, occasionally bending around massive objects like black holes due to gravitational lensing, a phenomenon first observed during a 1919 solar eclipse confirming general relativity, and now studied with precision by the Event Horizon Telescope, which imaged a black hole in 2019. Pause and reflect. How does it feel to grasp that a single ray of light can bridge the entire history of the cosmos without aging a second? Connecting this to Earth's story, our planet is but a tiny in this immense expanse, orbiting a modest star in the Milky Way's spiral arm, one of 200 billion stars in our galaxy alone, according to estimates from the Gaia mission launched by the European Space Agency in 2013. Planetary science facts reveal Earth's fragility in this vastness. Its thin atmosphere, just 60 miles thick compared to a 7,900-mile diameter, shields life from deadly cosmic rays, a protection not guaranteed on other worlds. The search for exoplanet mysteries deepens this perspective. The Kepler mission, active from 2009 to 2018, discovered over 2,600 confirmed planets, some like Kepler 452b, dubbed Earth's cousin, lying 1,400 light-years away in a habitable zone. Could photons reaching those distant worlds carry the same timeless story to alien eyes, if they exist? Modern technology like the James Webb Space Telescope is now analyzing these distant atmospheres for biosignatures, molecules like methane or oxygen, detecting light that has traveled for millennia, much like our photon. Earth's own history, marked by cataclysms like the Chicxulub asteroid impact 66 million years ago that wiped out 75% of species, reminds us how precarious life is amidst such cosmic scale, a fact reinforced by paleontological studies at the University of California, Berkeley. As you ponder this photon's unyielding path, consider researching the scale of the universe or exoplanet surveys. What vast distances or distant worlds intrigue you most? Let's carry this sense of cosmic wonder forward, transitioning to how the photon's journey illuminates the fragility and potential of life across the universe, deepening our appreciation for Earth while gazing outward through the lens of science. Let's continue tracing our photon's silent voyage, now considering how its timeless travel sheds light on the fragile yet boundless potential for life across the cosmic landscape, with Earth as our anchoring point of reference. As this particle of light streaks past ancient galaxies, some forming just 500 million years after the Big Bang as captured by the James Webb Space Telescope's infrared imagery in 2022, it carries no awareness of the worlds it might one day illuminate, yet its journey underscores the delicate conditions required for life to emerge. On Earth, life's existence hinges on a narrow set of circumstances: liquid water sustained by a Goldilocks distance from the Sun, a protective magnetic field deflecting solar radiation, and a greenhouse effect maintaining an average surface temperature of 59 degrees Fahrenheit, as documented by NASA's Earth Science Division. Our photon, indifferent to time, may have passed countless barren worlds before reaching us, worlds lacking these precise balances, a reality highlighted by studies of Mars, where evidence from the Perseverance rover since 2021 suggests ancient water flows but no current habitability. Reflect quietly. What does it mean that Earth, among trillions of possible planets, holds this rare spark of life to witness such ancient light? Astronomy reveals the staggering odds. With over 5,500 confirmed exoplanets as of 2023, per the Exoplanet Archive at Caltech, only a fraction, like Proxima Centauri b just 4.2 light-years away, lie in zones where water might persist. Yet even these face unknowns like stellar flares or atmospheric loss. The photon's journey mirrors this search for connection, having crossed voids where galaxies cluster in filaments, mapped by the Dark Energy Survey since 2013, perhaps brushing past worlds where life's potential waits to be ignited. Earth's own fragility is a humbling lesson. Near-extinction events like the Permian-Triassic die-off 252 million years ago, which eradicated 90% of species according to fossil records analyzed at the Smithsonian, show how easily life can falter, even on a planet so finely tuned. Technologies like the upcoming Large Synoptic Survey Telescope, set to begin operations in 2025, We'll scan for more habitable candidates, capturing light from distant systems as our photon has done, expanding our understanding of life's possibilities. This narrative of light and life invites a deeper emotional investment, knowing that Earth's ecosystems, from coral reefs to rainforests, hang by a thread as climate data from the IPCC warns of accelerating warming. We feel the weight of preserving our home while seeking others. What scientific discovery about life's origins or distant planets stirs your curiosity to learn more? As we follow this photon's path, let's transition to the philosophical implications of its journey, exploring how its timeless nature prompts us to question our own existence and connection to the broader universe through the lens of cosmic wonder and scientific inquiry. As we near the end of our photon's 14 billion-year odyssey, let's pause to reflect on the philosophical depths its timeless journey unveils, connecting its silent passage to questions of existence, Earth's role, and our place in the universal story. This photon, untouched by time due to the relativistic effects described by Einstein in his 1905 papers, embodies a paradox. While we age, build histories, and measure epochs, it remains forever in the present, a concept explored by physicists at institutions like MIT through thought experiments on light's frame of reference. Imagine if we could perceive reality as this photon does, where the Big Bang and this very moment are one. How would that reshape your understanding of life's fleeting nature? Tying this to Earth, our planet is a transient stage in the cosmic drama, formed 4.5 billion years ago from stardust. As isotopic analysis of meteorites by the Lunar and Planetary Institute confirms, yet it hosts minds capable of contemplating such ancient light. Planetary science facts ground us in this rarity. Earth's tilt of 23.5 degrees creates seasons, fostering biodiversity, a balance absent on many worlds like Venus, where surface temperatures reach 900 degrees Fahrenheit, per data from the Magellan mission in the 1990s. The photon's journey, passing through regions now studied via gravitational wave detections by LIGO since 2015, hints at a universe interconnected by unseen forces. Could our awareness, born on this fragile orb, be part of a larger cosmic consciousness? Exoplanet mysteries amplify this thought. The discovery of TRAPPIST-1's 7 Earth-sized planets in 2017, 3 in a habitable zone 39 light-years away, per NASA's Spitzer Space Telescope, sparks wonder about whether other beings might also gaze at timeless light and ponder their origins. Earth's history, scarred by events like the 1815 Mount Tambora eruption causing global cooling, as recorded in historical climate data, reminds us that life's persistence is not guaranteed, urging us to cherish and protect it. Technologies like quantum sensors advancing at facilities like Fermilab probe the fundamental nature of reality, perhaps one day revealing if light carries more than energy, if it links us to distant worlds in ways beyond physics. What philosophical question about time, light, or life's purpose does this photon story evoke in you? Let's carry this sense of introspection into our final reflection, weaving together the scientific marvel of light's journey with the emotional resonance of Earth's uniqueness and the endless quest for knowledge across the cosmos, inviting you to join this ongoing exploration. As we conclude this gentle journey with Earth with nature, let's rest in the profound story of our photon, a particle of light that has crossed 14 billion years without experiencing a single tick of time, connecting the universe's dawn to the very moment it touches your gaze. We've followed its path from the Big Bang's fiery birth, through vast cosmic distances mapped by tools like the Hubble Space Telescope, past galaxies and potential worlds unveiled by exoplanet mysteries, and into the heart of Earth's fragile beauty, illuminated by planetary science facts. We've marveled at how relativity, as theorized by Einstein and tested by experiments like GPS satellite time dilation corrections since the 1970s, renders time irrelevant for light, while pondering Earth's rare habitability, its liquid oceans, protective atmosphere, and life-sustaining cycles, so unlike the barren landscapes of Mars or Venus as studied by rovers and orbiters. The search for other habitable zones, driven by missions like TESS and the James Webb Space Telescope, reminds us that our photon may have passed countless worlds where life's potential waits, deepening our cosmic wonder. Earth's vulnerability, seen in mass extinctions and climate shifts documented by the Intergovernmental Panel on Climate Change, stirs an emotional call to safeguard our home while seeking answers beyond. Now, take a quiet moment. How does this timeless journey of light shift your view of time, life, or Earth's place in the vastness? If this exploration has ignited your curiosity, please like this video, subscribe to Earth with Nature for more immersive dives into science and the universe, and share your thoughts in the comments. Does the idea of light defying time inspire you, or what cosmic question will you explore next? Your engagement helps us craft more educational content on astronomy, planetary wonders, and the mysteries of existence, building a community of seekers. Thank you for joining me on this slow, thoughtful path. Keep questioning, keep researching, and remember, every ray of light holds a story of the cosmos, waiting for you to uncover its secrets.